In the history of science, one can often identify a familiar pattern. First, a phenomenon is discovered. Then its importance is established. Finally, the phenomenon is elevated into a central cause. Nitric oxide followed this trajectory. Once it became clear that nitric oxide participates in vascular and cellular function, a quiet assumption emerged. If the molecule supports function, then maintaining it should preserve function over time. This assumption appears reasonable. Yet reasonableness is not evidence. Nitric oxide is not a stable structural element. It is transient, localized, and highly dependent on context. Its short lifespan is not an inconvenience, it is a defining feature. This leads to a question that is rarely examined carefully: why does a signal designed to be brief now need to be sustained to keep systems working? In well-regulated systems, signals appear and disappear as conditions demand. They are not preserved. They are produced when required. When preservation becomes necessary, it usually indicates a deeper failure. Biological signaling does not operate independently. It depends on circulation, metabolic readiness, and the physical state of surrounding tissue. If those conditions deteriorate, a signal may still appear, but its effect changes. In such cases, maintaining the signal does not restore coordination. It merely keeps activity visible. This helps explain a recurring inconsistency in the literature. Measurements improve. Pathways activate. Yet functional outcomes remain uneven or absent. This discrepancy is often attributed to variability or compliance. But a more structural explanation may exist. Function is not additive. It emerges from synchronized conditions. Improving one variable while others degrade does not restore the original behavior of the system. From this perspective, nitric oxide resembles an indicator rather than a driver. Its presence reflects the state of the environment that produced it. Its absence points upstream. Attempts to maintain nitric oxide long-term may therefore be misdirected. They treat the signal as a primary objective rather than as evidence of system integrity. This reframing does not deny the value of nitric oxide research. It questions the hierarchy of causality. If nitric oxide must be maintained to preserve function, one must ask, what conditions have changed such that the system no longer generates it naturally? History shows that when scientific focus narrows too tightly, context is often lost. What was once an effect becomes a cause. What was once a sign becomes a target. The question, then, is not whether nitric oxide can be maintained. It is whether maintaining it recreates function, or only the appearance of activity. That distinction remains unresolved.